I'm Ravi Guntupalli. I'm a technology director within Cisco's mass scale infrastructure engineering team. So from Cisco's private 5G perspective, when we look at what the service providers do for consumer networks today, or even for enterprise networks, they typically build out a macro 5G network, right? So i.e. they have a bunch of towers that are built out nationwide, and the devices, your cell phones, connect back into that particular radio network, and then anchor back into a service provider packet core. As we went into 5G, one of the things that became fairly obvious for us was for enterprise customers, there are evolving set of use cases where they would actually want to have something like a private 5G network running on their premises. This is essentially your private radio devices that are deployed on your premises. So your existing network devices might actually support 5G and connect back into those particular radio. And then, because you're using a 3GPP defined radio access network, you'll have to have a mobility core as well. The mobility core essentially anchors your devices, whether it is IP packets or in the future Ethernet packets, coming back into the network. So you'll actually require a mobility core. And I have a bit of the architecture discussion in the next couple of slides. Yes.
I'm not in this space on a day-to-day basis. So explain to me what these use cases are where 5G is needed in industries.
Yeah. So I'll give you an example on a manufacturing floor, Ben, right? So typically what happens on a manufacturing floor is today, there are some devices that are connected back using wired connections, right? And there are some devices on the manufacturing floor that might actually require some monitoring, and they use Wi-Fi. As the new set of manufacturing floors are being built out, or even on the existing manufacturing floors, there are scenarios where the enterprise is saying, I need a little bit more guaranteed quality of service, right? Yes, Wi-Fi delivers a lot of that, but still you are operating in unlicensed spectrum. Whereas when you're talking about 4G and 5G, you're talking about potentially using what we call either a partially licensed spectrum, like CBRS in the US, in case you've heard that term, community broadband spectrum, or in some specific countries like Germany, they're actually allocating a spectrum specifically to be used for enterprise customers. Essentially, you have your own dedicated spectrum. So what that gives them is an ability to connect, in theory, an iPhone using a 5G connectivity back into their enterprise network. And as I go through the architecture, it'll become obvious, but just to set the stage, we believe that the use cases perspective, enterprise customers will actually look at private 5G as coexisting with wireless LAN. So going back to that same manufacturing floor, let's say it's a car manufacturer. And most of the devices might actually be able to connect back into a Wi-Fi network, and you're able to monitor those, but there are always going to be some corners where you need licensed spectrum. Or more importantly, that car might actually roll out of the manufacturing facility into a parking lot, and you may want to push a new software update into the car. When you're doing that, you're actually in this massive parking lot, and it becomes a lot more cost effective for them to actually use something like private 4G or 5G to push that software. So that's one use case. The other use case that we see actively being leveraged is mining industry, right? Mining industry has a lot of specific requirements on how the coverage needs to be. And for them, having a licensed spectrum like this, and especially being able to leverage something like 3GPP defined architectures, would become very viable for them. Does that help?
Yep, you did. You gave me the parameters to understand why we're even going down this path.
Absolutely. So yeah, and the interesting thing about a private 4G and 5G is a lot will be driven by the device ecosystem as well, right? So yes, most of the devices today that you procure typically have Wi-Fi built in. But as we see the maturity of the devices coming into the enterprise space, they will actually start having both 3GPP access spectrum as well as Wi-Fi. So it becomes like a call from the enterprise customer to say, yes, if I have that capability already in the device, why not use something like this, right? And just to extend that, some of the use cases, right? Take a FedEx delivery truck as an example, right? So FedEx might actually say, when my FedEx truck pulls into my facility and they're picking up the packages, I have Wi-Fi coverage, but as it rolls out, I might want to use private 4G and 5G networks. right? Or potentially even run on public 4G, 5G networks working with the service providers, right? So there's a combination of things that can be done to ensure you get the quality of service, you get the reliability as part of the network architecture. And then I'll cover a little bit of what that mobility core looks like in the next slide, right? Because again, from a simple Wi-Fi network perspective, traditionally we are used to what we call a wireless LAN controller, or the packets come from your access points into a single controller, and then you apply identity and policy on top. But 3GPP architectures have traditionally been designed for service providers who deliver massive consumer network, right? They're carrying hundreds of millions of devices on the network today. Whereas for private 5G, you don't need that complexity, right? So we're looking at how to simplify all of that stuff. So some of these components that you're seeing here, radios are essentially equivalent of our massive macro base stations that the service providers deploy. But for the enterprise use case, you would actually have a simplified open RAN-like architecture, or even a small cell potentially running on premises. Then you have the mobility core, which is essentially the anchor point of your network. That's where your sessions come in. That's where your packets come in for the first time. And we decide where to route those packets, whether into the enterprise network or not. And then, as always, you need an identity and policy engine, right? So how do I know who the device is? How do I authenticate the device? How do I authorize the device? And what kind of policy do I need to apply for that particular device? So when we looked at all of this components that the service providers actually deploy today, the challenge was, how do I make sure that this is super easy for enterprise customers? And Ben, you raise a very important point, right? You're not used to this domain, but you have a need potentially for an architecture like this, right? So our goal was to make it super easy to start with a private 5G network. And we've been working on private 5G deployments for a couple of years now. The biggest challenge that we see is to actually deploy this private 5G network on an enterprise premises. If you bring the full complexity of 3GPP, then it becomes a challenge, right? Because you as an enterprise customer are not used to seeing the complexity of 3GPP. How do we make it simple for you to start to get that ball rolling? And then how do we make it intuitive for you to operate it on a day-to-day basis? And one of the most important things we spend a lot of time on within Cisco is, how do we make sure this is secure? Right? Secure from your access perspective, secure from the device perspective. How do I tie into everything that the teams earlier talked about, right? Cisco SASE solutions. How do I make sure that SD-WAN can be leveraged, right? So all of those aspects come into this, and that's what we are offering right now. Right. So jumping a little bit into the architecture itself, and this is where a typical 5G network architecture comes in, right? So when I look at this from a service provider perspective today, right? A typical service provider typically has a bunch of other components. I'm only showing about 6 or 7 components here. When I look at the 3GPP network architecture, it could go up to 27 to 30 network functions in a service provider network. Do I need all of them, right? That's the challenge that we are faced with today. So on the far left-hand side, I show a set of devices and applications. The devices could be a AGV on the premises, or it could be a simple sensor that is monitoring, saying, hey, somebody opened the door for my power, right? That is a red flag for them, right? It could be as simple as an IoT device, or it could be much more complex, could be an AGV, or in the future could also be a remote surgery equipment. This could be a hospital on the left-hand side, somebody's doing remote surgery. They could also be connected back into a private 5G network. So the first thing that the devices would actually typically connect back into is the radio units. Radio units are essentially your access points. That's what's broadcasting the 3GPP defined spectrum and the signaling messages towards the device. The radio unit then connects back into multiple functions, a distributed unit or a centralized unit that manages the signaling, that brings in the packet from the device, authenticates back into a mobility and a session management function. All of these are required functionality for 3GPP. Essentially, the goal of this architecture is to be able to distribute some of these functions in different locations, but your identity always comes back to what we call a home subscriber server or a unified data repository, depending upon what you deploy, right? You have a 4G network, you have an HSS. You have a 5G network, you have a UDM and UDR, which I expanded for this discussion as unified data manager, and the repositories where your identity is used, right? And then you have an authentication function. The reason I'm sharing all of this is, as you see this architecture for the first time, it is overwhelming. I've been working in this industry for almost 20 years now in 3GPP. I live and breathe 3GPP networks. But when we talk to our enterprise customers, they're saying, look, we need the reliability of 3GPP. We need the quality of service capabilities that 3GPP brings, but we don't want to deal with the complexity of all of this. All we care about is, can we actually define policy? Can we get a reporting on how that usage is? Can I onboard my own devices? Right? As an enterprise customer, typically those are the questions we get back from our end users saying, look, I don't want to deal with the complexity of these 3GPP network functions. It's required, I need them, but I don't want to deal with it on a day-to-day basis. Right? So when we started building out all these private 5G networks, we said, this is not going to work for enterprises, right? That's why the title of this deck was Cisco Private 5G designed for enterprises, because what we did was we took the complexity of all of these network functions and made it a lot more simple. And a Tom Band animation, but I like this one. So on this one, basically what you see is a much more simplified view, a representation of what we are delivering as part of Cisco Private 5G networks. In this one, you still have this 4G and 5G radios, but they come back into what we call a 4G, 5G converged core. Most of the components that you saw in the previous slide, the dark blue boxes, get collapsed into one single UCS server that sits on premises. You, as the enterprise customer, never have to deal with the complexities of all of the acronyms that I was throwing earlier in the slide, right? So the SMF, UPF, where does the packet go? All of that comes back into one single server, making it akin to what Wi-Fi networks deliver today. And then the user plane function, which is where the first packet comes in, gets dropped off into your enterprise network or into your campus network, or potentially even into a public cloud using SD-WAN that John was talking about earlier, right? So you basically bring all of the packets back into the enterprise domain. All of that complexity gets buried into that converged core and a top layer here, which is our service management and the identity management layer. So as an enterprise customer, and I'll walk through the demo of this, you get to see your devices, you get to see your service as a whole, and you can lifecycle manage all of those capabilities via a single dashboard.
Just to be clear, when you're talking about private 5G, you're talking about operating in the CBRS band, is that correct?
So in the US, it could be CBRS band, but again, it could also be other spectrum, right? So specifically in the US, depends on who your service provider partner is, right? Let's say you go with Verizon. Verizon might say, hey, I have millimeter wave spectrum that is very unique for Verizon and AT&T, right? They might offer that. T-Mobile might say, I have some extra spectrum in a different spectrum band that I can offer to the enterprise customers, right? While most of the activity we are seeing in the US is around CBRS, because CBRS has the generally available licenses, we do anticipate that both PAL licenses from CBRS, other spectrum in the US will be leveraged. Right?
And the other question that I have is for onboarding those end user devices. I know that you're simplifying the complexity on the infrastructure side, but I'm still going to either need to pop a SIM card or have some kind of eSIM capability into my endpoint device in order to be able to see that network and join it, correct?
Absolutely, yes. And even on that front, Tom, we simplified that capability as well. So you do not have to deal with the SIM manufacturers. We will be providing the SIMs, or even your service provider's partner could be providing the SIMs, right? The end goal for us was to actually either use eSIMs, which are slowly building up in the network, or provide SIMs that have already been onboarded. All you have to do is pop them into the right device and say, I've now pushed this device into service. I want to activate the service, right? So I'll walk that in the demo portion as to exactly how you can actually manage that on a day-to-day basis.
Thank you.
Right. Okay, and then from the enterprise customer perspective, one of the things they've always liked is having API access, right? Yes, UX dashboards are great, which I'll demo today, but we do know that some of the power users like to manage most of this via API access. And so we do expose APIs not bound to actually provide lifecycle management of the service as a whole, right? So that is available. But the idea on all of this is, here's a private 5G network or a private 4G network that you can deploy on your enterprise network, get a different service that you're used to today, or potentially, more importantly, the way we see it is this private 5G network should not be a standalone island, because any enterprise that we talk to today, they tell us that they have multiple access networks. They have Wi-Fi, they have wired network, and the device could potentially be connected to one of those 2 or 3 different network access types. So one of the things that we've spent a lot of time on our private 5G network is how do you bring all of these different access types and have the enterprise customers primarily focus on your identity and policy management. So we bring all of those different packets and different access networks back through a set of different core networks. You're definitely used to wireless LAN controller. Now you have your private mobility core. Cat9K could be your fabric. How do I bring all of those packets back from your different core and connect back into a simple identity services engine? So from 3GPP perspective, you still have to authenticate the device using 3GPP protocols, right? So when you power on your cell phone today, you're still doing your SIM authentication. You're either doing a SIM or an eSIM authentication. Then you get authorized into what we call the identity services engine from Cisco, which is fairly popular in the enterprise domain. And the idea is to be able to define your policy once. So when the SIM gets onboarded, and Tom, to answer your question, right? So you have secure onboarding of the SIMs. And once the SIM gets onboarded, we push that identity towards both our mobility core as well as enterprise identity services, right? That way, the enterprise basically says, okay, look, I have this SIM that I just plugged into my AGV. I want to manage the AGV policy. I'm not going to manage my SIM policy. Right? That's what we wanted to enable as part of this. So we are now authorizing all of those capabilities into this centralized identity services engine where you define the policy once, and when the packet is actually traversing through your network architecture, it could be connected on your 3GPP network, it could be connected on a wireless LAN, or get dropped off into a different fabric. Everything gets the same policy treatment. Right? We wanted to make that simple so that the 5G network does not stand as an island in your network architecture, but rather gets tightly integrated into the enterprise. Right? The other thing that we also saw was how do I actually bring the same device potentially could move into a service provider network. To Tom's earlier point, CBRS could be used in my enterprise network here to broadcast my private 4G, 5G. But that same device could potentially move into a macro cellular environment, i.e. the likes of the Verizons in the US or the DT in Europe or other customers, right? So when the device actually goes out there, we want to be able to provide the same service back via the service provider core, but get the same policy in that network. So we do have some capabilities where you can actually define the policy once in your enterprise network, and that same policy gets pushed out both in your private 4G, 5G network, but also again, get applied in your service provider network. Right? So again, our goal was to make sure that this is all simple. I know I threw a lot of acronyms at you guys today, but at the end of the day, you will not actually have to deal with that complexity of 3GPP. Our goal was to make sure you focus on the orange boxes here, focus on your day-to-day business, focus on your device management, which is essentially what you do today for your Wi-Fi devices as well, and make it super simple to actually define policies once and get the service policy defined across the different access networks. I have a window here which basically shows our UX primarily from Cisco Private 5G perspective. I've just populated some of the credentials there. I'm just going to go ahead and log in. So this is a role-based access control for different personas. And the persona that I just logged into for this particular system is what I call an enterprise IT admin. I know there was an earlier question in the previous demos as well as can I define multiple personas in the enterprise? Absolutely, right? That's what this tool actually allows, where you might have a different level of IT personas within your enterprise where you say, I have one person that is actually responsible for defining this private 5G network as a whole for the entire enterprise footprint. But within a single factory floor, there's a second IT person who's responsible primarily to make sure that my SIMs are working fine. So you can define two different roles or personas within your enterprise that basically says, here's a network administrator and here's a device administrator. What I've logged into the system right now is as the network administrator. And this is the typical screen that gets presented. I'll start over from the dashboard and we'll walk through some of these other capabilities, right? So when I click on the dashboard here, what you get to see is what's happening with my service as a whole. Right? So when I look at this, all of the 3GPP complexity that I was talking about earlier, right? Whether it's the SMF, UPF, all of those other acronyms, you don't have to deal with that. Our idea was to deliver this as a service to you as the enterprise customer. You want to see what's happening with my network. Everything looks green here. All of those components in the dark blue box get deployed on an edge network. And then you also get a visibility of what's happening with my radio network, right? So everything looks healthy here. I'm running this out of my Boxborough lab, so you get to see what's happening in that network. The other thing that we've also done is give the control to the enterprise administrator to say, what do they want to see on a day-to-day basis? As an example here, I can go in, click on my dashboard, decide I don't want to see the throughput on a day-to-day basis because I don't care much about the throughput. I can disable that, right? So that goes away versus typically we do see a lot of enterprises wanting to see what's happening with my network from throughput perspective, right? And then there's a lot of trending information as well. We've been doing a lot of demos last week. So as you can see, there's throughput over a period of time, what was happening in the network. I could go back and look at the history as well. But as scroll down here, you look at the number of sessions as well. A session typically is a device connecting back into your private 4G, 5G network, i.e. your internet connection into the enterprise that is coming back in from an iPhone or a robot or an AGV. All of those are counted as sessions. All of that visibility is provided over a period of time as well. And then data usage, again, the difference between the throughput versus data usage is throughput is what's happening at that particular instant versus data usage is what was happening in my network over a period of time, how much data have my devices been consuming. And I'll explain in a second as to why we wanted to share that information. Right? Then you have devices deployed as well. Somebody yanked some of my devices, so I see only 0 of them, but eventually I think I'll show you guys a little bit more details in here, right? So that's the first dashboard here, essentially what the enterprise customer sees on a day-to-day basis to operate this particular service. The second one I wanted to share today is network management. And as a network management here, if I go in, very similar view of what's happening with that particular HQ site, click on that, have a look at my site. And here you get to see the edge status. And the edge in here is essentially what's running on your premises as the enterprise. And it includes all of the 3GPP network functions that are running, right? So it's a single UCS server with a lot of other capabilities pushed in. And then you get to see the health of the radio as well. And what's more important here is that if something critical is happening with your network, you get to see that as an alert that comes in. But the important thing about this is you don't have to worry about debugging the network on a day-to-day basis. We, Cisco, are delivering this as a service. So our SRE team is responsible for making sure they address any open issues that are occurring in the network at any given time. The other thing that you get to see as well is the number of devices that are in session versus how many that are available. And Tom, to your earlier question, this particular enterprise has actually ordered 5,000 sessions or 5,000 devices, right? They actually have those, but they've only inserted 4 into the devices. And so I clicked on that, and now I get to see the devices in that particular network, right? And this is where we believe most of the enterprise customers will spend their time, right? Because this is their day-to-day business operations, whether that particular device is a sensor versus a robot. How do I define policy for that, right? And this is where the device grouping is very important. And we wanted to give this control of the day-to-day lifecycle management of your devices to the enterprise customer. And the reason I'm spending a little bit of time on that one is typically what happens in your consumer devices today. If you want to change a policy, or if you want to sign up for a new service, you have to call the service provider or go on a login dashboard and define your policies for that service provider, right? Whereas in the private enterprise case, we wanted the enterprise IT team to be able to control what they do with the devices on a day-to-day basis, but they get to define the policy, right? As an example here, I'm going to go filter on my sensor. And you'll see I have about 5 sensors that have been deployed and the SIM has been activated, right? But they're not in session. And this is where the IT administrator might say, oh, something's wrong. I had this particular device actually connected previously, but it's no longer connected. What's happening, right? You can run diagnostics on this. You can run basically a click here and have a look at what's happening with my device. My device has been provisioned successfully. My device has passed all of the SIM capabilities, but something's wrong with my network connection. It could be as simple as power cycling the device. In a typical phone, if it's an iPhone, you could actually set it into airplane mode, bring it back into service. It would connect back, right? So if I did the extended demo of this one, you would actually see, like, I can actually change some of the device status to airplane mode and bring it back, and it'll connect back into the network. And the other thing I could always do is go back and look at what happened with this particular device historically, i.e., has it ever connected to the network? As you can see here, this particular device has never connected to the network. It has the SIM provision, but it's never connected to the network. And so this is what we call the Spotlight tool. So if I clear my status here, I'm going to pick one of these devices, which is a Zebra industrial device, and look at the status of what's happening with that particular device. This basically shows a device is not provisioned. So if I go back here, run my test, somebody went in and deactivated the device at a particular time. So somebody in my TME team is actually out there testing this. So they went in and deactivated. I could go ahead and say, oh, you know what? I want to activate this particular service. So you, as the enterprise IT team, have the flexibility to go in and say, I need to change my device status from deactivated to activated. And this brings the device back in session, right? So now it's actually connected. I can go back in and see what would happen with that particular device. It's running the test, and device is provisioned, network connection is successful. I actually have an IP internet connectivity. Right? Again, the reason I'm spending so much time on the device tab here is we believe this is what the enterprise customers are going to use more on a day-to-day basis, right? You don't want to deal with the complexity of the 3GPP network functions. You want to focus on running your business on a day-to-day basis. The other thing that I can also do here is assign rate plans. And for this particular demo, we had only created a test rate plan. And what the rate plan does is allows you to define quality of service. As an example here, right? The sensors here might actually only require 10 kilobits per second data throughput, whereas my robot here might actually require gigs of throughput. You get to define those rate policies and say how I actually want to manage some of the service attributes for that particular device. But the trick here is, if you look at a traditional 3GPP architecture, you have to define that in a policy server. Instead of that, we are connecting this back into the Cisco ICE system. That way you define the policy in Cisco ICE, and the same policy gets applied for the device if it's on Wi-Fi or on the 5G side. We can bring those policies back into the 3GPP network as well. All right, so we wanted to make sure this is tightly integrated into the enterprise architecture, though it is delivering the 3GPP network architecture into the enterprise. On top of that, you could also basically look at some automation capabilities here. I could actually define this as SIM swap prevention. Let's say something's happening in the network. Somebody decided to pop the SIM card from one device and popped it into a different device without notifying somebody. You could get a trigger. You can define a lot of different capabilities here. One of the cool examples that we've seen our service provider customers and enterprises use is like what's happening with the device as a sensor. If the sensor is only supposed to be doing 10 kilobits per second, but somehow it's suddenly doing 1 megabit, somebody might have hacked it, right? So it's transmitting a lot more data than it's supposed to. So you can actually define a lot of different triggers, get notified, and we actually track all of this stuff so that, like, if a debugging session was done and we have a solution for this, you can define a solution. That way, the next time it happens, the solution is displayed to that IT team to say, hey, you need to try something else. All right, so going into the deployment, this is the part of the demo that we did not do today in the interest of time, but the idea around the onboarding experience being simple as well is if I look at a service provider 3GPP network today, there's almost about 2,000, 3,000 lines of CLI they configure. But you don't need that full complexity in an enterprise network, right? So we boiled down the set of configurations down to about 18 parameters. And these 18 parameters are parameters that you, as an enterprise team, will be very familiar with. For example, what are my IP pools going to look like? What is my NTP server, right? What is my DNS information, right? So we've kind of boiled down that information so this becomes super easy for you to onboard and deploy on your enterprise network on a day-to-day basis. And this is, again, a demo that we didn't show today, but absolutely can be done in a subsequent day. Then easy to operate, obviously, we spend a lot of time on the operations aspect today, on how the enterprise customer sees this. The other thing that I didn't show today as part of the demo was what happens if I have multiple sites as an enterprise, right? You would actually have visibility as a network administrator to see what's happening at every individual site as well through that common dashboard. And you could also define API alerts and triggers.